This question is about EMF, and it's the EMF generated by having a rotating coil within a magnetic field. So we're told that we've got a coil with a number of turns with a certain diameter, and it's placed in a uniform field, and then it's turned. And the crucial bit is the fact that it's turned. If it doesn't move, there's no EMF generated, and it turns through 90 degrees. So that turning through 90 degrees means it goes from the being sort of side on to being full. So in terms of the area swept out is the full cross-sectional area of the loop of the coil. Looking at the data sheet again, we can see that we've got a number of formulae given to us for magnetic fields. The relevant one is the magnitude of the induced EMF. So epsilon induced EMF is n number of turns, and it's the rate of change of magnetic flux per unit time. So what we've got then is that the EMF is equal to n delta phi over delta t, but this is also given as B multiplied by A. So it's the magnetic field strength B multiplied by the cross-sectional area. So actually you could rewrite it as n delta BA delta T. Actually, B's constant, so really it's the change in area that we're interested in. So that's where this rotation comes in. So we end up with number of turns, which is given to us in the question, which is 20. Then we have the magnetic field strength, which is 90 millitesla, so 10 times 10 to the negative 3 Tesla. Then the area, so it goes from being side on, effectively having no area, to the full area. So the change in area is pi r squared. It gives us a diameter, 60 millimeters. So again, be careful of that. So we need to change that to a radius, times 10 to the negative 3, and don't forget to square it. So it's r squared, all over the change in time. Now it tells us it takes 0.2 seconds to rotate to 90 degrees. And we're also told to assume that this is uniform. So we can average it out. So we just need to do this calculation then to get the EMF. So once we've got all that, we just need to then put it in our calculators. So 20 times 90 times 10 to the negative 3 multiplied by pi multiplied by 30 times 10 to the negative 3 times 30 times 10 to the negative 3 to get it squared, and then divide by 0.2. And we get 0.025. It's an EMF, so it's a voltage. I can use the ENG button, and it gets me it in millivolts, so it's 25 millivolts.